Alright, good day everyone. So welcome back to my YouTube channel, and this is Catholic and Vlogs. And our topic for today is all about algebraic substitutions. This is integral calculus. So there are cases for algebraic substitution. The first one is when the integrand contains fractional powers of x only. Use a substitution. So we have here the substitution z is equal to the nth root of x, or z raised to n is equal to x, where n is the least common denominator of the fractional exponent of x. So number two case is if the integrand contains the fractional powers of a plus bx only. Use a substitution, this one. Alright, so this is a substitution where n is the least common denominator of the fractional exponents of a plus bx. And number three, if the integrand contains the expression x raised to m, a quantity a plus bx raised to n p over q, where m and p and q are integers, n and q is greater than 0, and if m plus 1 over n is equal to integer, we have to use the substitution. So we could make use of this case number 3. If that is case number 4, if the integrand contains the expression x raised to m, quantity of a plus b raised x raised to n, p over q, where m and p and q are integers, and n and q is greater than 0, if m plus 1 over n plus p over q is an integer, use the substitution x raised to n, z raised to q is equal to a plus bx raised to n. And the fifth case is if the reciprocal of substitutions, and this is reciprocal substitution wherein you have to let x is equal to 1 over z. So some integrals with a rational integrand may be evaluated by letting x is equal to 1 over z. And 6 and 7 are somewhat related. If the integrand contains the expression like this, a plus the square root of a plus bx plus x squared, use a substitution, a plus bx plus x squared is equal to the quantity of z minus x squared. And if the integrand contains the expression is 1, a plus bx, we could factor, use of substitution, a plus bx is equal to a plus x quantity squared z squared. Again, those are the 7 cases of algebraic substitution. So we have to take it step by step from 1 to 7 the case, and I will be giving you example for each case. So let us have first number 1. So integral of dx over x minus x raised to 2/3. So the first thing that we're going to do is we're going to take a look with a case. This is case number 1 because when the integrand contains the fractional powers of x, so this is x only, so we have here, so we have to let z raised to z is equal to the nth root of the square nth root of x, nth root of x, or z raised to n is equal to x. So first, where n is the least common denominator of the fractional exponents of x. So first is we have to let this one. So z raised to n. So we have here the least common denominator, which is 3, right? In this case, so 3. So therefore, we have here z raised to cube is equal to x. Alright, so z cube is equal to x, or this one. We can make use of this one or this one. So let us have first this z cube is equal to x. What we're going to look into is we need to get the substitutions, or the value for dx, the x, and x rather. So the value of dx and x, because they have the same x, we could simply substitute using x later. So what is the value for our dx? Since we have now the value for x, which is z cubed, we have to look for the value for our dx. So to find for dx, we have dx is equal to the derivative of this one, dx is equal to 3z squared. dz. So we have now the value for our dx, which is this one. Again, what we're going to do here is we need to substitute the value using z. Okay, all the values here will be substituted using z. Okay, so we have now the integral of, okay, the integral of, what is the value for our dx, which is 3z squared dz, over, what is the value for x? Our x is equal to z cubed minus, we have here z cubed raised to 2/3. Okay, cancel. So therefore, integral of 3z squared dz is over z cubed minus z squared. So we have here, we can factor out this part. So we have 3z squared dz over z squared, factor z squared, we have z minus 1. Okay, so cancel this part. So the remaining is 3, the integral of dz over z minus 1. So we have here, we have to let our u is equal to z minus 1, our du is equal to dz. So therefore we have here 3, the integral of du over u. So integral of du over u is equal to the ln. So 3 ln of u plus c. So therefore we have here 3 ln. What is the value for our u? We have z minus 1 plus c. But still, we need to perform the value for z. What is the value for our z? Our z is equal to z cubed is equal to x. So therefore, to get for the value for our z, we have to raise it by 1/3. So we have here z is equal to x raised to 1/3. So therefore, 3 ln of x raised to 1/3 minus 1 plus c. So this is the value. So that's the case number 1. We could rely on case number 1. So let's proceed now with number 2. So integral of dx, we have here over the quantity of x plus 2 raised to 3/4 minus the quantity of x plus 2 raised to 1/2. So the part here is we have here in the form of a plus bx. So therefore, we could make use of z raised to n is equal to a plus bx. So what is our least common denominator of 4 and 2? So therefore, we could make use of, okay, what is the least common denominator of 4? Of 2, we have 4. So therefore, we have z raised to 4 is equal to 2 plus x. Okay, x plus 2. 2 plus x or x plus 2. So to find for, since what we're looking here is we need to find for dx, and the value, since we have now the value for x plus 2 here, so what we're looking here is dx only, because now we have the value for our 2 plus x or x plus 2 rather. So we have here, we have the value here is x. We could transform this one as x is equal to z raised to 4 minus 2. So dx is equal to 4z cubed dz, because it is 0, the constant. Okay, so 4z cubed dz, so we have now the value. So integral of 4z cubed dz over, what is the value for x? The value for our x is, okay, we have the value for x, which is z raised to 4 minus 2. So we have here z raised to 4 minus 2. Still, we have here the 2 here, plus 2 raised to 3/4, and minus z raised to 4 minus 2 plus 2 raised to 1/2. Okay, so we have here to integrate this part. So we have 4 z cubed dz over we could simplify this one. We can make it 0, and we have to simplify this part. We have cancel 4. We have z cubed minus, and this is z squared, right? Because this is 4 1/2, this is z squared. So therefore we have here z raised to cube minus z squared. Okay, so first we could factor z cubed here. So in the integral, no, we have z squared rather, z squared. So we have here 4 z cubed dz over z squared times z minus 1. Okay, z minus 1. So cancel this part. So therefore 4 integral of z dz over z minus 1. So we could make use of this one since we could not let this immediately for u. So we have to divide. So divide here. So z minus 1 divided by z divided by z minus 1. So therefore this is z divided by z1. So this is z, and this is minus 1. Ano, here, not here, minus 1. Again, z divided by z, that is 1. 1 times z, that is z, and 1 times negative 1, that's 1. So therefore negative 1. So the remainder is, the result is 1 minus 1 over z minus 1. So therefore we have here 4, the integral of 1 minus 1 over z minus 1. Okay, this is z minus 1 dz. Okay, so we have to perform the distributive. So 4 integral of dz minus 4 the integral of dz over z minus 1. Okay, so the integral for dz is equal to 4z minus 4. If we're going to let u is equal to z minus 1, and du is equal to dz. Okay, so therefore this is du over u. So therefore this is ln. So ln of z minus 1 plus c. So now we have to find the value for our z. So what is the value for our z? So the given here is z is equal to x plus 2. To find for the value for our z, we have to raise it by 1/4. Okay, we have to raise it by 1/4. So therefore this is z is equal to x plus 2 raised to 1/4. So that is the value for our z. So therefore 4x plus 2 raised to 1/4 minus 4 ln of x plus 2 raised to 1/4 minus 1 plus c. So this is the final answer for number 2. Okay, so 4 plus 4, that's quantity of 1. This is 1. Quantity of x plus 2 raised to 1/4. Okay. So this is rather, no, this is plus, by the way. Change the sign rather, just change the sign. This is plus, and this is plus. Okay, I have to make a correction. This is plus. So 4 plus ln of x plus 2 raised to 1/4 minus 1 plus c. Okay, so we have now in number 3. So in number 3, we have here case number 3. So the integral of x cubed, the square root of 1 plus 4x squared dx. So we have first, if the integrand contains the expression x raised to m, a plus bx raised to n, and p raised to q. So if that is the case, this is the format here. So where n and p are q integers, and q is greater than 0, and n plus 1 over n is equal to integer, we have to use a substitution, which is z raised to q is equal to a plus bx raised to n. So here, the first thing that we're going to do is we have to find the value for Rm. Rm here is equal to 3, and what is next? What is n? Rn is equal to 2. So therefore, m plus 1 over n is equal to 3 plus 1 over 2, that is equal to 2, which is, this is an integer. So therefore, we could make use of the substitution zq is equal to a plus bx raised to n. Okay, so next we have here the first part. Okay, so the first part here is we have to find the value for our q. Our value for our q here in this case is, what is the value for our q? Our q, z squared. Okay. Our q here is, since this is 1/2, we could express this one as 1 plus 4x squared raised to 1/2. Our q here is equal to 2. Okay. So therefore, we could make use of z squared is equal to 1 plus 4x squared. Okay, so that is our z. Next in line, we have here to find for the value for our dx. So we have now the value for this part. Okay, can we have now the x? So later we'll find for the x, but we have to find first for dx. To find for dx, we have to perform this operation. So this is 4x squared. So we have here take divided by z raised to 4 minus 1 over 4 is equal to x squared. So we have to square root both sides. So x is equal to the square root of z raised to squared rather, z squared minus 1 over 2. So this is the value for our x. Now we have to find for the value for this part, which is dx. Our dx is equal to, we could express this one as 1/2 z squared minus 1 raised to negative 1/2. So therefore, we have here, right, 1/2 and times negative 1/2, based on this negative 1/2, times z squared minus 1 raised to negative 1/2 minus 1. Okay, negative 1/2. Okay. Oh, this is not negative, so 1/2 rather. Okay, 1/2. 1/2 minus 1 times the derivative of this one is 2z. Okay, and dz. So this is dx is equal to negative 1/4 times 2z raised to z squared minus 1 raised to negative 1/2. Again, this is 1/2 minus 1. And this is dz. So cancel this part, cancel this part. So remains z here. So dx is equal to negative, okay, negative, this negative, not negative rather, because this is positive, So we have here z dz over c squared minus 1. Okay, still we have 2 here because we have 2 raised to 1 half. Okay, so this is the value for our dx. So dx is equal to z. Again, we have to recap. So dx is equal to, this is positive rather, 1 half. This is still, we have 1 half here. In taking the derivative, put it down. Here, 1 half, z squared minus 1, 1 half minus 1, times the derivative of the inner, which is 2z dz. Since we have to simplify, 1/4, 2z, cancel, that is equal to 2 here. And z squared minus 1 raised to negative 1 half, it becomes positive when you put that one in denominator, and this is, the remaining here is z. So dz dz. So now, we have to simply substitute the value for this part. Since we are looking for this substitution, so we have the integral of, what is our x? The value for x is equal to z, the square root of z minus 1 over 2 cube times, what is the value for this part? The value for this part is 1 plus the square root. So we have to look here, 1 plus the square root. So if you're going to take this square root, okay, the value for is equal to z. So therefore this is z times our dx here is z dz over 2, okay, the square root of z minus 1. Okay, next we can simplify the integral of, we could express this one as z minus 1 raised to 3 halves over 2 times 2 times 2, we have 2 times 2 for 8 times z dz over 2, and this is z minus 1 raised to 1 half. So since this is 3 halves and you have to deduct it by 1 half, the remaining is z minus 1. Alright, z minus 1 raised to 1. Alright, so 3 halves minus 1 half, that is equal to 1. Okay, so the integral of this one is z minus 1 times, alright, so we have here z. Still we have z here. Okay, times z squared dz. Cancel this part here. And the remaining is z minus 1 over 16. Okay, over 16. Next, we have here 1 over 16. The integral of, this is z. Okay. Okay, what is the value for x? Z squared. Rather, this is z squared. This is z squared. And this is z squared. And this is z squared. Sorry, I forgot to write z squared. So this is z squared. So therefore, we have z raised to 4. Alright. Z raised to 4 minus z squared. Quantity dz. So 1 over 16, this will become, okay, we have z raised to 5 over 5 minus z raised to cube over 3. We have to integrate this and plus c. Okay. So we have here 1 over 16. Okay. So this is, the LCD is 15. So this is 3z raised to 5 minus 5z cubed. Then plus c. So 1 over 16, we have to simply substitute the value for our z. The value for our z is 3. We have the square root of 1 plus 4x squared raised to 5 minus 5, 1 plus 4x squared square root raised to 3 over 15, then plus c. So we have here over 216 times 240. Okay, we could express this term as 3 times 1, the square root of 1 plus 4x squared raised to squared, so that we could extract, right? And this is 1 plus 4x squared, square root, raised to 3 minus 5, the square root of 1 plus 4x squared cube, then plus c. Okay, so we could plus, this is plus, we could simplify this part as 3, 1 plus 4x squared, being scratch the square root, and we have to factor this part, so minus 5 times 1 plus the square root of 1 plus 4x squared cube over 240 plus c. Simplify first further. So we have here 3 plus 12x squared minus 5 and times 1, we could express this one into fraction, 4x squared raised to 3 halves over 240 plus c. So this is 3 minus 5, that is equal to 2. So 2, so this is 2. Alright, this is 2, and we could factor 12 here. This would become 2, and this is 6x squared. 6x squared minus 1 times 1 plus 4x squared raised to 3 halves over 240 plus c. The final answer is 6x squared minus 1 times 1 plus 4x squared raised to 3 halves over 120 plus c. Again, this is the final answer. Okay, so this is number 3. So I hope you listened. And for case number 4, dx over the integral of dx over x squared 1 plus 4x raised to 4 raised to 3/4. So first thing that we're going to do is if the integrand contains the expression x raised to m. Okay, x raised to m. Okay, x raised to m. A plus bx raised to n p over q. So we could make use of the substitution if the integer is m plus 1 over n plus p over q is equal to integer. Okay, so x raised to n, z raised to q is equal to a plus bx raised to n. So this is the substitution that we're going to make use. Okay, so in this case, we could internalize it one that we could raise it up here. So we could have x raised to negative 2, 1 plus x raised to 4 raised to negative 3/4. So in this case, what is our m? Our m is equal to negative 2, our n is equal to 4, our p is equal to negative 3, our q is equal to 4. So by simply substituting here, m plus 1 over n plus p over q, that is equal to negative 2 plus 1 over n, which is 4, plus negative 3 over 4 is equal to negative 1. So therefore, this is an integer. So we could make use of the substitution x raised to 4, z raised to 4 is equal to 1 plus x raised to 4. So in this case, we have here the substitutions. Okay, x raised to 4 in this part. So x raised to 4, z raised to 4, 1 plus x raised to 4. So we have to find the value for this part. Okay. So here, since we are looking for dx, we have to transform this one into x. So how to transform this part? So you have to group here x z raised to 4 minus x raised to 4 is equal to 1. So here we could factor x raised to 4, and this is z raised to 4 minus 1 is equal to 1. So therefore we have z raised to 4 minus 1 is equal to 1 over x raised to 4. So we have z raised to 4 minus 1 is equal to x raised to negative 4. So square raised to negative 1/4. Okay, so cancel this part. So our x is equal to z raised to 4 minus 1 raised to negative 1/4. So to find for the derivative of this part, we have here dx is equal to negative 1/4 z raised to 4 minus 1 negative 1/4 minus 1, that is negative 5 over 4, and times derivative of this one is 4z cubed dz. Okay, so cancel 4 here. So the answer is dx is equal to negative z cubed dz over z raised to 4 minus 1 raised to 5 over 4. So this is the value for our dx. Okay. Next we have here substitution. So we have to simplify further this part, or we could just simply put there up this expression. So in this case, the integral of what is the value for our dx, we just have to put it up. So we have negative z cubed z raised to 4 minus 1 raised to negative 5 over 4. We have dz over, so what is the value for our x squared? Our x here, so we have to locate the value for our x. Since we don't have yet the x, so we have to perform the value for our x. Here, we have here the value for our x rather. This is the value for our x. Our x is equal to z raised to 4 minus 1 raised to negative 1/4 times. So what is the value for our here? 1 plus x raised to 4 raised to 3/4. So we have to find for the value for this part. Since in this case, we could simply substitute using this part here. So to make this become 3/4, we have to raise all it by 3/4. So x raised to 4, z raised to 4, oh my god, z raised to 4 is equal to 1 plus x raised to 4. We have to raise it by 3/4 so that we could be able to copy here like this. Okay. So the remaining here is x cubed z cubed is equal to 1 plus x raised to 3/4. Since we don't have yet the value for our z here, our x rather, so we have to simplify further. So we have z raised to 4 minus 1 raised to negative 1/4, and we have to raise it by 3. Z cubed is equal to 1 plus x raised to 4 raised to 3/4. Okay, so the value for this part is we have z 4 minus 1 raised to negative 3/4 and z cubed. So this is now the value for our 1 plus x raised to 4 over 3/4. So this part. So we have to write here z raised to 4 minus 1 raised to negative 3/4, okay, and z cubed. So in this case, we could cancel this part, okay. So negative 1/4 plus negative 3/4, okay. Again, so this is raised to, alright, we have to raise it by 2. So the remaining here is z raised to 4, okay, minus 1 raised to negative 1/2. Okay, okay. So negative 1/2 and negative 3/4. When you add this one, so negative 1/2, okay, plus negative 3/4, you have to find for the LCD switch 4, and this is 4 divided by 2, that is equal to 2 times 1, this is negative 2, plus negative 3. Okay, so therefore negative 2 and negative 3, that is negative 5 over 4. So negative 5 over 4, so the integral of this part is z raised to 4, since we have cancelled the already, z raised to 4 minus 1 raised to negative 5 over 4 over, when you add this part, this is z raised to 4 minus 1 raised to negative 5 over 4 dz. So the remaining here is cancel this part. So we have here the integral of dz. Okay, and this is negative rather. This is negative dz. Okay, negative dz. So the negative integral of dz is equal to negative z plus c. But we have to find for the value for our z. How to find the value for our z? Our z here, so we have to look for the z. Okay, we don't have yet the z, so we have to look for our z. How to find for the value for our z here? This is the first equations. So we have x raised to 4, z raised to 4 equals 1 plus x raised to 4. So we have to look for our z. Okay, so to look for our z, so you have z raised to 4 is equal to 1 plus x raised to 4 over x raised to 4. You have to put here 1/4 to find for the value for our z. Okay, you have to raise it 4 by 4. So you have z is equal to, this will become 1 plus x raised to 4, and x raised to 4 times 1/4 over x. So now we have now the value for our z. So negative, the value for z is negative z. We have 1 plus, and this is 1/4. X raised to 4, okay, this is x raised to 4 raised to negative, raised to 1/4 over x plus c. Okay, so this is the value, which is negative 1 plus x raised to 4 raised to 1/4 over x plus c. That's it for number 4. This is case number 4 also. In case number 5, so the x squared 1 plus x raised to 4 raised to 3/4, we have to let x is equal to 1 over z. Since we have here x 1 over z, we could express this one, and x is equal to z raised to negative 1. So our dx is equal to negative z negative 2 dz. Okay, so dx is equal to negative 1 over z squared dz. So what we are looking here is, we have now the value of dx, x, and no more, because we have to substitute here the value all of this x. Okay, so let's start substituting now. So this is negative 1 over z squared. This is the value for our dx. over 1 over z squared, right? Because you could have x when you raise this 1 as squared, so still this is squared, this is squared, so the result is 1 over z squared, right? So 1 plus 1 over z raised to 4 raised to 3/4. Okay, so next we have cancel this part. Okay, so negative the integral of dz, we have to simplify. Find the LCD. We have z raised to 4, z raised to 4 plus 1 raised to 3/4. Okay, so next step is we have to simplify first. Negative dz, we could have this part as z raised to 4 plus 1 raised to 3/4, and we have z raised to 4 negative 4 raised to 3/4. So we have the remaining here, cancel this part. So we could have negative the integral of dz over z raised to 4 plus 1 raised to 3/4 and z raised to negative 3. Okay. So since we have to put it in the numerator, so z raised to 4 plus 1 raised to negative 3/4 and z raised to 3 dz. Okay, so first next step is we have to let this one as our u. So u is z raised to 4 plus 1. Our du is equal to 4z cubed dz. So our nf is equal to 1/4. So we have to integrate. Okay, negative the integral of u raised to negative 3/4, and this is 1/4 dz. Okay, so it's negative, so we have to simplify. So negative 1/4. Okay, you have u raised to negative 3/4 plus 1 over negative 3/4 plus 1 plus c. So negative 1/4. Okay, negative 3/4 plus 1, that is equal to 1/4. Okay, 1/4. U raised to 1/4 over 1/4. Then plus c. So cancel this part here. The remaining is negative u raised to 1/4 plus c. So what is our u? Our u here is this. Okay, negative z raised to 4 plus 1 raised to 1/4 plus c. Okay, so since what is the value for our z? Our z now would become negative 1 over x raised to 4 plus 1 raised to 1/4 plus c. So take the LCD, negative x raised to 4, 1 plus x raised to 4 raised to 1/4 plus c. So this is now the value for our integration. Okay, negative or no, we have that simplified first. Here, 1 plus, sorry, x raised to 4 raised to 1/4, because we could still simplify this part here. So x plus c. If you have observed, in question number 5 and number 6, they have the same answer, right? By using number 4 case and using number 5 case. So the same answer, because the same integration but different process. Okay, so let's now proceed with number 6. In number 6, we have the integral of this part. Then we have to let 6 minus x squared is equal to 3 plus the quantity of squared, c squared. This case number 7 or 6, this is number 7. 6 and 7 are somewhat like the same. Okay, so in this case, we have here the factor of this part is 3 plus x, and this is 2 minus x. So if this is the same here, so we have here 3 plus x, 2 minus x is equal to 3 plus x squared z squared. So the first thing that we're going to do is we need to find for our dx. So cancel first this part. So 2 minus x is equal to 3 plus x z squared. Okay. So find the derivative of this one. We have dx negative. Okay. So take the product here. So copy 3 plus x udb. That's the derivative of this one, 2z dz plus z squared copy times derivative of this one, which is dx. So next we have two combined. So negative dx minus z squared dz is equal to 3 plus x, 3 plus x, 2z dz. Okay, so simplify negative 1 minus z squared dz is equal to 3 plus x 2z dz. To find for this is right, dx, rather, dx. To find for dx, we have extract negative first here, negative. So 3 plus x 2z dz over 1 plus z squared. Okay, so 1 plus z squared. So now we could simply substitute here the value, the integral of. What is the value for our dx? The value for our dx is equal to negative 3 plus x 2z dz over 1 plus z squared, then over the value for this one is the square root of, okay, the value for this one is the square root of 3 plus x squared z squared. Okay, next we could have, okay, the integral of this part is, take the reciprocal, yes, negative 3 plus x 2z over 1 plus z squared times the reciprocal. When you take the square root of this one, that is equal to 3, oh no, here 1 over, okay, 1 over 3 plus x, because we can extract square root, over z. So in this part, we have cancel this part, and z. The remaining is negative, the integral of 2 here, and this is, we have here dz rather, dz. So dz over 1 plus z squared. Okay, 1 plus z squared. So this is inverse trigonometric functions. We have to let u is equal to z and du is equal to dx, or a is equal to 1. So negative 2, and this is tangent. So therefore we have here 2 tangent of, inverse tangent of z over 1 plus c. So therefore we have negative 2 inverse tangent of z plus c. Since we don't have yet the value for our z, so we have to look for here. So 2 minus x is equal to 3 plus x z squared. So 2 minus x over 3 plus x equals z squared. Square root. So the value for our z is equal to negative 2 inverse tangent of the square root of 2 minus x over 3 plus x plus c. So this is now the final answer. So I hope you understood about this topic. So if you have questions, just raise the messenger or you could comment down. Alright, so we have here the try this. Evaluate each of the following using the cases that I gave you a while ago. So 1, 2, 3, 4. So good luck and God bless everyone. And do not forget to subscribe my channel, Kasaligan Vlogs. Thank you for listening.